This is what happens when a star dies. And sometimes, like in the case of this red giant, it creates something even more dangerous. When a star dies, the specific fate you're hinting at is a supernova explosion. And the something even more dangerous it can leave behind is one of two cosmic nightmares. One, a neutron star, specifically a magnetar, or two, a black hole. So let's start with neutron stars. When a massive star between 8 and about 20 times the mass of our sun runs out of nuclear fuel, its core implodes, collapsing under its own gravity. This collapse is so dramatic that it crushes the core to an unimaginable density. Imagine squeezing the entire mass of the sun, which is about 2 million trillion kilograms, into a sphere just 20 kilometers wide. That's the size of a neutron star. To make matters crazier, these objects have a crust, a thin outer layer, typically only a few hundred meters thick, but with a density around 10 billion times that of water. The stuff that makes up the crust, atomic nuclei packed so closely together that electrons can't tunnel through them, meaning they don't conduct electricity. But that also means that if you were foolish enough to stand on the surface of a neutron star and remove your shoes, you would never get a shock. Why is all this important? Well, a lot of neutron stars, about 1/3 of them, are born with crazy strong magnetic fields called magnetars. These magnetic fields are so powerful, they are quadrillions of times stronger than the Earth's magnetic field. Here on Earth, we experience magnetic fields on the order of 10 to 100 microtesla. On a neutron star, they can reach 1,000 megatesla. To put that into context, if you placed a compass on the surface of a neutron star, the magnetic field would be strong enough to rotate it almost 90 degrees in less than 1 second. And that's just the magnetic field of the star itself. You also have the magnetosphere. This is a region around the neutron star where the magnetic field lines extend outward into space, forming a huge bubble that traps charged particles like electrons and positrons. When these charged particles move along the magnetic field lines, they generate electric currents. And because the magnetic field of a neutron star is so incredibly strong, these currents can generate electromagnetic radiation that blasts away from the star at near the speed of light. This radiation is known as an extra-high-energy photon, and if a magnetar happened to be pointing its magnetic pole at us, a single stellar flare could deliver hundreds of thousands of these X-rays and gamma rays every second. This barrage of radiation is called a gamma-ray burst. Now, it wouldn't affect the Earth directly. The Earth would still spin on its axis and orbit the sun as usual, but it would have one catastrophic effect. It would strip away our planet's ozone layer, leaving Earth vulnerable to the sun's deadly ultraviolet radiation. Now, we do have a layer of atmosphere that absorbs much of the sun's ultraviolet radiation, but it's not sufficient protection against a flare of this magnitude. For comparison, the last time a similar event occurred on Earth, it caused a mass extinction. It happened 252 million years ago when a massive underwater volcano in what is now Siberia erupted, spewing tons of gases and ash into the atmosphere. Scientists believe this volcanic winter blocked sunlight, triggering a chain reaction that led to oxygen depletion in the oceans. Many marine species died, including 96% of coral reefs and 70% of land-dwelling vertebrates. What's scary is that the next mass extinction could happen sooner than we think. Our ozone layer has already thinned by 4% since the 1960s. If a gamma-ray burst from a magnetar hit Earth today, we'd be in trouble. Luckily, magnetars and gamma-ray bursts are rare. There have only been about 30 magnetars discovered in our galaxy so far. Gamma-ray bursts occur once every couple of 100,000 years, and thankfully, none have been found within 3,000 light-years of Earth. But it's only a matter of time before we find one, and the chances are good that there will be at least one pointed toward us. Okay, now let's talk about black holes. Black holes are another thing that can happen when a really big star, one that weighs over about 20 times the mass of our sun, runs out of nuclear fuel. In fact, Scientists think that many of the black holes lurking at the centers of galaxies were born this way. When a gigantic star collapses, the core implosion is so powerful that it collapses the core beyond the surface of a neutron star. Nothing, not even a neutron, can halt its descent into a black hole. So instead of being confined to a sphere 20 kilometers wide, everything gets crushed into a single infinitesimal point. This point, called a singularity, has a radius called the Schwarzschild radius, which is inversely proportional to the mass of the black hole. So the more massive the black hole, the smaller its Schwarzschild radius. The Schwarzschild radius of a 20 solar mass black hole is about 3 kilometers across. At this point, the rules of physics as we know them break down. We have no idea what actually happens inside the singularity. The only thing we know for sure is that nothing can escape the black hole's grasp once it crosses the event horizon, the boundary of the Schwarzschild radius. Once something crosses the event horizon, it can never come back out. Not even light, which is why it's called a black hole. No light can escape from inside. Now, you might say, okay, so what's the big deal? It's not like people go missing inside black holes all the time, are they? Well, here's the problem. The thing is, black holes don't just sit there. They grow. Their immense gravity warps space-time around them, creating a sort of cosmic whirlpool that sucks in everything that strays too close. Dust, gas, asteroids, planets, even other stars. In fact, I lied when I said that black holes don't go around consuming things. They do. It's just that they tend to be pretty far away. Most of the black holes in the Milky Way are thought to be between 1,000 and 100,000 light-years away. Even so, if one of those black holes had a mass around 100 times that of our Sun and was orbiting a giant cloud of gas and dust, it could literally rip apart and devour our entire solar system. Yes, all 8 planets and the Sun itself would be sucked into the black hole's gaping maw. Now, luckily, such a scenario is very unlikely to happen anytime soon. The nearest black hole to our Sun is about 3,300 light-years away. And even though black holes can travel at incredible speeds, given enough time, they would eventually wander into our neck of the woods. One study published in 2020 used computer simulations to model the behavior of black holes in the Milky Way and estimate that our Sun could get dangerously close to a black hole roughly once every 100 billion years. Unfortunately, our Sun is much closer to the center of the galaxy than most stars, which means that we're likely to encounter a rogue black hole long before our time comes. According to NASA, the odds of a rogue black hole wandering into our solar system in the next 100 billion years are about 1 in 7. But if we were to survive the impact of a rogue black hole ripping through the inner solar system, we probably wouldn't survive the consequences either. All the planets would be flung out of their orbits, crashing into each other and the Sun in a cosmic catastrophe that would end all life on Earth. Yeah, so either way we're gonna die. But hey, at least we won't be bored. If you enjoyed this video and want to learn more about the incredible phenomena that threaten our existence, please consider checking out our previous videos. Thanks for watching, and we'll see you next time.